So welcome back. Uh, in this video, I'm going to give you an example of Bayes' theorem, a very special case, simple situation. So let's read the problem here. The problem is the probability that a person with certain symptoms has hepatitis is 80%. So you go to the hospital with all these symptoms, whatever those things might be, and the chances are you have hepatitis 80% of the time. 20% of the time you don't have hepatitis. And to confirm whether a person has hepatitis or not, they do a blood test. And the blood test confirms, if it's a positive test, it confirms 90% of the time, yes, this person has the disease, has hepatitis. And if a person goes there with symptoms but doesn't have hepatitis, 5% of the time it shows the person has, the test shows the person might have hepatitis. So this 5%. Now the question is, what's the probability that the individual has the symptoms and test positively actually has hepatitis? That's the question we have to answer. As I mentioned before, anytime you want to apply Bayes' theorem, Bayes' formula, it's very tough to remember the formula. Therefore, what you need to do is draw a tree diagram that makes your life very simple. So let's see. H stands for hepatitis. H prime is exactly the opposite. Opposite means the person doesn't have hepatitis. And these two probabilities should add up to 100%, right? Either you have it or you don't. And if you read the problem, it says 80% of the people with those symptoms will have hepatitis. So the chances are, if you have all those symptoms that appear in you, 80% chances you have hepatitis, 20% chance it's a false alarm, really don't have. And you do the test to confirm it. If you have hepatitis, if you do the test confirms 90% of the time, yes, you do have hepatitis. So this is 0.9. So those who have hepatitis and do the test, blood test, 90% of the time it gives you positive result, okay? Whereas 5% of those without the disease. So if you don't have hepatitis, and if you do the test, the chances it might say you have hepatitis is 0.05, 5%. Okay? So really we have two paths here, ending in T plus. T plus means positive test. So you compute the probabilities here. So if you want to compute the probability along each path, you multiply the probabilities. So this is 0.8 times 0.9. And here, choose the path that ends in T plus. So the probability is 0.2 times 0.05. 0.2 times 0.05. Okay? Sometimes the tree diagram might be too big. In this case, you are looking at all those paths that end in whatever event you're looking at. So now the question, what's the probability? So here you're given probability of T plus given hepatitis. You have hepatitis, what is the probability the test is positive? That's what this is. Probability of T plus given H. Now the question is, you want to find probability of H given T plus. The test is positive. What are the chances that you really have hepatitis? That's what you need to find. As I mentioned in my previous videos, the Bayes theorem is usually used to find the opposite of what you have here. So if it's given P of T plus given H, they will ask you to compute H given T plus. The formula is, you take this number, the opposite of that, H t plus given h, that number in the top, 0.8 times 0.9 divided by sum of these two. So 0.8 times 0.9. So that number always appears in the bottom along with other stuff, other numbers. In this case, you have only two of them. And you compute this, and that will tell you exactly the probability that the test is positive, that you have hepatitis. I think I let you compute this. It gives you around 83 or 84%. I don't have a calculator with me. Compute this. Okay? And this is an example. So to summarize, I already have two other videos. This is the third video. So I want you to watch all three videos, and when you try to apply Bayes' theorem, don't forget to write down the diagram, tree diagram. That would help you to write down the formula. Okay? Thank you.